Hi everyone, I'm Cheryl. In this exercise, we're asked to find the gradient of my function h at the point 2 pi over 4, and then we want to find the maximum value of the directional derivative at that point. So let's begin with the gradient. So the gradient of h of xy is going to equal the partial with respect to x of xy times my vector I plus the partial with respect to y of xy times my vector j. So if I'm taking the partial with respect to x, I want to treat y as a constant. If y is a constant, so is the tangent of y. So my first partial is just going to be the tangent of y times my vector I. When I take the partial with respect to y, I'm going to treat x like it's a constant. So I'll take my constant multiple of x and then the derivative of the tangent of y, which is secant squared y, and then that gets multiplied by my vector j. All right, now I'm interested in the gradient at the point 2 pi over 4. So I'll plug in x equals 2 and y equals pi over 4. So I've got the tangent of pi over 4 times my vector I plus 2 times secant squared of pi over 4 times my vector j. So this is 1 times my vector I, because the tangent of pi over 4 is 1, plus 2 times the secant squared of pi over 4. Well, the secant of pi over 4 is the square root of 2, so we'll square that and multiply it by my vector j. So I have I plus, this will be 2 times 2, or 4, times my vector j, and that's my gradient. Now the second part of this problem asks me to find the maximum value of the directional derivative at the point 2 pi over 4. Well, that occurs at the norm of my gradient. So in this case, I'm going to have the square root of 1 squared plus 4 squared, or the square root of 1 plus 16, or the square root of 17. And that's the maximum value taken on by the directional derivative at the point 2 pi over 4. I hope that was helpful. Thanks.